Dear student, myself Rajendra Aaseri, I am assistant professor in computer science department at Government Bangalore PG College, Didwana. Today we are going to learn some new aspect about data types. So C in C there are some basic data type we have already covered. Now there are some important concept about these. Size and pointer difference types. First point, separate size underscore t and ptr diff underscore t. These two types are used to represent memory related quantities. Existing types were inadequate. Why we are using this? Because existing data type, which were primitive data type, were inadequate because their size is defined according to the target processor's arithmetic capability. Now here, not the memory capabilities, such as the address space availability. Both of both of these above types are defined in a special header file named as stdef.h, standard definition header file. It is in another header file in C++ named as cstddef. Next, size underscore t data type is used to represent the maximum size of any object. It means if you want to know what is the maximum size of any object, including array, then we need to use size underscore t data type. It is used in a particular implementation. An unsigned integer type used to represent the size of object size underscore t. Some programming example also listed below. Now in sample output, some lines of code or lines of output are dictated here. First line of output, size underscore t is 4 byte. It indicates that the size underscore t data type takes how many byte? 4 byte in the memory. It consumes 4 byte in memory. Next line of output is x as unsigned decimal is 25. Means I have displayed one value in decimal form. The value is 25. Now x as octal is corresponding decimal value 25 and corresponding octal value to it is 31. In decimal the base is 10, in octal the base is 8. Now the corresponding hexadecimal value, if I want to display, then x as hex is 19. So 25, 31, 19, and next is signed decimal 25. All are same values in different base. X value under unsigned decimal 25, under octal 31, under hexadecimal it is 19, under signed decimal it is 25. So if you want to exit this output screen, then we have to press any key. Now next, C in C we use a return type of the size of operator. So size of operator is having a return type int, means when we apply any parameter in size of, it will return an integer value. Example, if I'm writing size of in bracket int, it will return 4. 4 is number of byte of, or we can say size of integer data type. If you are writing size of in bracket char, it will return 1. 1 means 1 byte for the character data type. The maximum size of size underscore t is provided by size underscore max. Size underscore max is nothing else, it is a macro which we can say it is a macro constant which is defined in the stdint.h header file. In C++, it is cstdint header file. It is guaranteed to be at least of size 65535. ptr diff underscore t data type is used to represent the difference between pointer. ls is signed integer type of the result of subtracting two pointer. The type size is chosen so that it could store the maximum size of theoretically possible array of any type. On a 32-bit system, ptr diff underscore t will take 32 bits, and similarly on 62-bit it will take 64 bits. 64 bit it will take 64 bits, and it is portable. So there are two data types. One is size underscore t and second is ptr diff underscore t. Next example, a sample output is listed here. If you look on the screen, so the first line is value of p point A is 24 and P point B is 45. Now corresponding address, if I want to display, value is size underscore T, and if address, then PTR diff. So address of P point A is 12FF48 and P point B is 12FF3C in this particular memory system. The size of PTR diff underscore T is 4 byte. It consumes 4 byte in the memory. The difference between two pointer is 3 byte difference. The difference between two pointer, if you want to display in another format, then it displayed as FFFFFFD. Next, interface to properties of the basic data type. Now information about the actual properties such as size of the basic arithmetic type is provided by macro constant in two header file. First header file is limit.h header file. As the name implies, it will show you the limits. In C++, the similar header file name is C limits. It defines a macro for integer type. Now macro is nothing else. It is basically we can say a string constant which will be replaced by its value before the compilation. So it is also known as pre-processor directive, whose value will be replaced with its name before the processing. Before we compile the program, macro value will be replaced with its name. So limits.h is first header file. It defines macros for integer type. Now next header file name is float.h. Similar header file in C++ is cfloat. It defines macros for floating point type. We can perform operation on integer as well as floating point. So if we want integer type of operation macros, then limits.h header file will be suitable, and if we want floating point type of value, then float.h header file will be required. Now the actual values depend upon the implementation. Means in integer, sometime integer take 2 byte and sometime it take 4 byte. It depends upon the architecture, computer architecture of the memory. So if we want to talk in detail about the macros, then we can say macro is basically we can say a string constant, and corresponding there will be a value. Example, suppose I want to calculate area of a circle, then the formula of area is pi r square. So in C program we need to write down pi is unknown to the C program, so at place of pi I have to write down either 3.14, or if I am using a constant pi, then I have to define pi as macro before the header file. Now how to write down that? So to write down that, I have to write down a line with the header file hash define studio.h. It is for printf and scanf. Now next I have to define the macro hash define. It is basically a keyword. Hash is preprocessor directive. Define is keyword space. I have to write down now macro name. Here macro name is pi space macro value. So macro value here is 3.14. So in this line it will be read as hash define pi 3.14 semicolon. So when I have to write down a formula for the area of the circle, then I have to write down area equal to pi into r into r. So when we compile this program, before the compilation, pi, that is string constant or macro, that value is 3.14. 3.14 will be replaced with pi. So compiler will read area equal to 3.14 into r. It will not read pi because macro value will replace macro name before the compilation. So in this manner we can reuse pi as many places as we want. We need to define only macro once, and we can use the macro as many places as in our program. So that's all about the data types. In the next lecture we will put some more light in detail about the basic data type or the various aspect of the data type in C program. Corresponding programs will be discussed. We will be doing some programs also based on the data type. Thank you so much.